Hello everyone. What we'd like to do in this video is just solve some more trig equations. Specifically, we're going to be solving trig equations where we have trig equations that are squared or situations where we might need to do some factoring. Okay, let's look at our first example. So let's say we want to solve the equation. How about 4 sine squared of theta minus 3 is equal to 0. So the first thing we're going to want to do here to solve for sine is, let's go ahead and isolate sine squared. So we can add 3 to both sides and divide by 4. So we'll get that sine squared of theta will be equal to 3/4, or we'll get that sine of theta could be equal to the plus or minus square root of 3/4, which is equivalent to the plus or minus square root of 3 all over 2. Make sure not to forget the plus or minus. So whenever we have equations that are a little bit more complicated, we always just want to reduce these equations down to just a set of simple or basic trig equations. Here I have 2 equations I need to solve. I need to know, when is sine of theta equal to root 3 over 2, but also when is sine of theta equal to negative root 3 over 2. So we need to solve each one of these separately. Okay. We could do this without a calculator. These are nice numbers on the unit circle, but if they're not nice, we'll want to take the sine inverse of both sides. So sine inverse of root 3 over 2. Similarly over here, theta will be equal to the sine inverse of negative root 3 over 2. Let's solve this one first. Let's draw a unit circle. Okay. We want to know when the height is root 3 over 2, so that's when the y-coordinate is root 3 over 2. That'll be at pi over 3. So this angle right here. This is the one our calculator will tell us. Sine inverse spits out angles between negative pi over 2 and pi over 2. So we have this angle here, pi over 3. This will be one solution. Plus 2 pi k. But there's another location where we have a height of root 3 over 2. That's right here. This is the one the calculator won't report to us. We need to think about what this angle here is. So what's this? It's this obtuse angle. Okay, well, a great way to think about it is to note that from here to here is still an angle of pi over 3. So we can just take pi and subtract pi over 3. Or how about we take 3 pi over 3, that's equivalent to pi, and we take away a pi over 3, and we're left with that, we're at 2 pi over 3. So this is 2 pi over 3. So theta equal to 2 pi over 3 plus 2 pi k. Okay, let's do this second one over here, and we'll draw our unit circle. Okay, now we want to know when the height is negative root 3 over 2, and let's put a 2 here. So negative root 3 over 2 will be right here. So your calculator is going to spit out this angle. Calculator will spit out this angle right here. Okay, remember, sine inverse spits out angles between negative pi over 2 and pi over 2, so it's actually going to tell you this negative angle right here. Okay. I hope you believe that that is negative pi over 3 plus 2 pi k. So here, in any multiple of 2 pi. But we have this other one here that the calculator is not telling us. So we'll need to think about how to get here. So theta could be equal to, well, let's see what we can do here. We kind of want this larger angle right here. So we could think about, I guess, notice that the reference angle right here would still be pi over 3. So we can take pi and we can add another pi over 3. So we have 3 pi over 3. This is the same thing as just pi, plus an extra pi over 3. So this angle here will be 4 pi over 3. We also have 4 pi over 3 plus 2 pi k. And here are our solution sets to this problem. So you could put negative pi over 3 here, or if this was the larger angle, that would be the same thing if you weren't necessarily, I guess, thinking about what your sine inverse would spit out. That angle, this would be equivalent to what you could take 2 pi, so how about 6 pi over 3, and take away a pi over 3, so that's 5 pi over 3. So 5 pi over 3 and negative pi over 3 are coterminal. You could replace those if you like. This is totally fine how it is, though. But what I would like to comment is, while this is a correct solution set, there is a nice way that we could condense this specific solution set. And if we look at the unit circle, hopefully see if we kind of put these together. Maybe that's what I'll do. If we kind of put these together, here's that other red solution right here. And we also have, kind of go across, we have this other green solution right here. So I'm kind of condense these two unit circles together. Well, notice that we could have written the solution set as, let's see, well, we could start at pi over 3, and we could add actually just pi. We could go halfway around the circle to get here, and we could jump back and forth. So pi over 3 plus pi k, or we could do theta. So whether you wanted to do negative pi over 3 and add back and forth, you could do that. You could do negative pi over 3 plus pi k, and that's going to jump back and forth between here. Or you could have replaced this with 2 pi over 3, started here and jump back and forth. Either would be fine. So this would be a perfectly good solution set. And maybe even a way you could condense this even more is you could write this as the same thing as theta, which is equal to plus or minus pi over 3 plus pi k. Wow. Fun. So either of these answers where you have these 4 written out, you kind of condense it down to 2, or we can have this very kind of neat, compact way to write the solution to this equation. Pretty cool. I think this is why it's really great to draw unit circles for these problems. Okay, so you're just going to want to make sure to pay attention to what the problem is asking. If it's hopefully it's kind of maybe guiding you to which form of the solution you'd want to give. Okay, let's do another one. Let's have you try one. Okay. How about go ahead and pause the video and try to solve 4 cosine squared of theta minus 2 equals 0. Go ahead and give this a shot. Okay, let's do it. So let's first isolate cosine squared. We'll have that cosine squared of theta will be equal to 2/4, which is the same thing as 1/2. We could take the square root of both sides. It actually, for this specific problem, it might be nice to leave it as 2/4. So maybe we'll do that. But we do the plus or minus square root of 2/4, which is the same thing as plus or minus what? Root 2 all over 2. Now, if you just would have reduced it to 1/2, I just kind of was able to see where this problem was going. But if you had reduced this to 1/2, you'd get cosine of theta would be equal to 1/2 cosine squared. Take the square root of both sides, plus or minus. This is the same thing as the square root of 1 over the square root of 2, plus or minus 1 over root 2. And you could have just rationalized the denominator by multiplying top and bottom by root 2 over 2. And we'll get to the same location, or the same result. So either way. All right. So we have two solutions we need to solve, or 2 equations we need to solve. We have cosine of theta will be equal to root 2 over 2, or we have that the cosine of theta could be equal to negative root 2 over 2. Okay. Maybe for this one, we could try to solve both of these. These are nice numbers on the unit circle, so maybe we won't even need to use our calculator here. Okay, well, you want to know when the x-coordinate is root 2 over 2. That's when the x-coordinate is root 2 over 2. That's right here. Right here. And right here. See, root 2 over 2 should be negative root 2 over 2. So right here, this x-coordinate right here is root 2 over 2. This x-coordinate right here is negative root 2 over 2. We're trying to find these solutions. Drawing a unit circle here and not using our calculator, I think, will be useful. Okay, we got to get to all 4 of these spots. Okay, so how about we start here? So this could be theta, could be equal to what? Pi over 4. Pi over 4, now to get over here, we could add a multiple of pi. Plus pi k. Or theta could be equal to, well, maybe the easiest way to get to these is saying this is negative pi over 4. Negative pi over 4, and we could add pi k. Or we could say, I think maybe a clean way to write this is theta could be equal to plus or minus pi over 4 plus pi k. And here is the solution. Okay. You could have written this out into 4 different pieces. You know, you could have done pi over 4 plus 2 pi k. You could have done 3 pi over 4 plus 2 pi k. 1, 2, 3, 4. 5 pi over 4 plus 2 pi k. 1, 2, 3, 4, 5, 6. 7 pi over 4 plus 2 pi k. So you could write it into 4 pieces. You could have written it as 2 pieces, or you could condense it down and write it into 1 piece here. Either way will give you the correct answer. Okay. Let's do a problem where the numbers aren't so friendly to us. Okay. How about we want to solve about 9 times sine squared of theta minus 1 equals 0. Go ahead and pause the video and give a shot at solving this equation here. Okay, let's do it. So let's first isolate sine squared. So we'll have sine squared of theta will be equal to 1/9. So we'll have that sine of theta will be equal to the plus or minus square root of 1/9, which is the same thing as plus or minus 1/3. Okay, so we have 2 equations to solve. We have sine of theta could be equal to 1/3, or we could have sine of theta could be equal to negative 1/3. Might be nice to draw the unit circle here. Okay, so we need a height of 1/3. So here's a height of roughly 1/3. Okay. So this length right here is 1/3, but we also want when the height is negative 1/3. So here's negative 1/3. So we need to hit all 4 of these locations. These are the locations that'll be a solution to this equation. Okay, so let's try to think about how to get them. All right, so let's do, this is a nice number on the unit circle. So we'll need to do sine inverse of 1/3. Okay, so let's do sine inverse of 1/3. So I'm getting that theta is going to be roughly, let's do 0. Let's see, if I'm rounding to 3 decimal places, I'm getting a 0.3398. If we're going to 4, that'll bump this up to a 0, which will bump this up to a 4. So 0.340. So theta could be equal to 0.340. Okay, and now we can just add pi to jump back and forth between these locations. So plus pi k. Well, this angle right here is 0.34 radians, but I can get to this one just by going backwards. So we could also have, so now I'm thinking about when it's equal to negative pi over 3. I guess this 0.34, that was this part, that was this solution, and then when I'm jumping over pi, I'm solving this part of the equation. So we could also do theta could be equal to, well, this will be a negative 0.340, and now we could add multiples of pi to jump back and forth. Okay, so for this one right here, this is a perfectly fine solution if you want to just have two of them. Okay, but you could also say that theta could be equal to, how about plus or minus 0.34 plus pi k. So this would be a way to condense it down to just one set. If you wanted to have, like, I guess 4 sets, you could have what? You could have this one right here. That's what, 0.340. If you wanted to get this one right here, you could just do, you know, pi, take pi and subtract 0.340. That'll give you this piece right here. So you'll have this one, add multiples of 2 pi, multiples of 2 pi, multiples of 2 pi. To get to this one, you could take pi and subtract 0.34, and you could have that location add 2 pi, add 2 pi, add 2 pi. Okay. To get to this one right here, just do the negative 0.34, add 2 pi, add 2 pi, add 2 pi. If you want to get to this one, you could say pi plus 0.34, and you could have that location plus 2 pi, plus 2 pi, plus 2 pi, plus 2 pi. And that's if you wanted to write it into 4 separate pieces. Okay, let's go ahead and try this next example. For this one here, we have to realize that this is an equation that's quadratic in form. So to help see this, I'm going to make a substitution. You don't have to make a substitution, but I find it easier just to kind of visualize this. So let's call y the sine of theta. And let's make that replacement. So here we'll get 2y squared plus 5y minus 3 is equal to 0. So this equation here is a quadratic, but I've kind of turned it into a quadratic in y. So we just need to solve this quadratic. So we could use the quadratic equation. We could use, I would avoid the quadratic equation. I guess you could complete the square too, but I think we're just going to try to factor this. Now there's plenty of methods for factoring something like this. There's a great box method. There's kind of like this guess and check method. I prefer to use the AC method. So for the AC method, I think about a quadratic is in the form of, a quadratic equation is like ax squared plus bx plus c equals 0. So for the AC method, we take the a and the c, we multiply them together. So we take the 2 and the negative 3, multiply those together to get out a negative 6. And now we want to find the factors of negative 6 that add to the middle coefficient or add to our b. So factors of negative 6 that add to 5. Let's see, I think 6 and negative 1 will work. These multiply to give negative 6, and they add to give 5. So now what I'm going to do is I'm going to take this, this quadratic right here, and I'm going to split it so it has 4 terms. So 2y squared plus, instead of 5y, we'll write that as 6y plus a negative y. So notice all I've done is wrote 5y as 6y plus a negative y, or 6y take away a y. So haven't changed anything. But what's great is I've taken this quadratic and now I've written it as a, basically I've written it so it has 4 terms. Whenever you see any sort of polynomial that has 4 terms in it and you want to factor it, factoring by grouping is a great thing to try. So we'll group the first 2 terms and the second 2 terms. And we'll look at each of these set of parentheses, and we'll look for the greatest common factor in each of them and factor that out. So I think we can factor out a 2y out of these parentheses. And we'll be left with what? A y plus 3. Now, for the second set, when I factor something out of it, I want to make sure it's going to be a y plus 3 also. So I need to factor out a negative. So let's factor out, how about a negative 1? And we'll be left with now a y plus 3. It's still equal to 0. Okay. Well, now I've taken this polynomial that had 4 terms, and now have basically written it so it has 2 terms. And each of these terms has a common factor of y plus 3, and we can take that y plus 3 and factor it out front. So this will be a y plus 3 times a 2y, a 2y, a 2y plus negative 1, or how about a 2y minus 1? and this is still equal to 0. Okay, so from here what we're going to do is we're going to use what's called the zero product property. So we have two things being multiplied to give you 0. If you don't remember the zero product property, this says that if you have two numbers a and b that multiply to give you 0, this implies that either a is equal to 0 or that b is equal to 0. So hopefully this makes sense. Try to think of any two non-zero numbers that multiply to give you 0. I can't think of any. If you can think of any, you're going to win a great math prize, because I don't know, there isn't any. Okay, so what this says here is this says that we could either have y plus 3 could be equal to 0, or we could have 2y minus 1 could be equal to 0. If we solve for y, we'll get y is equal to negative 3. Over here, we could add 1 and divide by 2, so y would be equal to 1/2. Okay, so don't go ahead and say like, oh, I'm so excited, we got our answer. Remember, we're not trying to solve for y here, we're trying to solve for theta. We need to remember that y is the same thing as sine of theta. So what we need to solve now is sine of theta equal to negative 3, or that sine of theta will be equal to 1/2. Okay, so let's write that up. So we've taken this trig equation, and we've now broken it down into two basic trig equations that we can solve. So let's write those up here. We need to solve sine of theta equaling to negative 3, and also sine of theta being equal to 1/2. All right. So maybe if we're maybe not thinking and just kind of going through the motions, you might say, oh, well, negative 3 isn't one of those nice numbers on the unit circle, so maybe you take the sine inverse of both sides. So sine inverse of negative 3. We'll pull out our calculator and we'll see what it tells us. Let's see. The sine inverse of negative 3. Beep, beep, beep. Beep, 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 beep. Beep, beep, beep. The calculator's beeping at me. What's going on here? Error. Domain issue. What's going on here? Well, remember that the domain of sine inverse is between negative 1 and 1. Sine inverse can only eat numbers between negative 1 and 1. This should make sense because, well, sine of theta, what are the outputs of sine of theta? Well, sine of theta has an output, or has an amplitude of 1. Sine of theta only spits out answers between negative 1 and 1. So there's no angle that such that the sine of that angle will spit out negative 3. There is no solution for this piece right here. This makes no sense. However, over here, 1/2 is a nice number on the unit circle, but if it wasn't, we want to take the sine inverse of both sides. So sine inverse of 1/2. Let's go ahead and draw the unit circle. Okay, so we want to know when the y coordinate is 1/2. So that'll be right here. Okay, this angle here is pi over 6. Or you could use the hand trick. If you put down your pi over 6 finger, the y coordinate is root 1 over 2, or 1/2. So there's this location. This is the one the calculator will tell you. But there's also this location here, which we need to keep track of. So our solutions will be theta, will be pi over 6 plus 2 pi k. Or, what else? Well, this angle right here, the reference angle here, would be pi over 6. So to get to this larger angle, this obtuse angle, we could take what? 2 pi? Pi, or how about we do 6 pi over 6 is equivalent to pi, and we take away a pi over 6. And so that should be 5 pi over 6. So 5 pi over 6 plus 2 pi k. If you didn't like that, you could just, how many pi over 6s does it take to get there? 1, 2, 3, 4, 5. 5 pi over 6. So here is the solution set to this trig equation here. Fun. Okay. Let's do another one. Let's have you try one. Okay. Try solving. How about 8 cosine squared of theta is equal to 3 minus 2 cosine of theta. Pause the video and see if you can solve this here. Okay, let's do it. The key thing to realize for this problem is it's quadratic in form. I have a cosine being squared, I have a cosine to a second power, but I also have a single power of cosine, so this is screaming at me that this is quadratic in form. Okay, so we could make a substitution. So we could say y is equal to the cosine of theta. So we'd have a 8y squared would be equal to 3 minus 2y. Okay, so what we're going to want to do here, since this is a quadratic, is we're going to want to move everything to the left-hand side and have the quadratic equal to 0. So we'll get a 8y squared plus 2y minus 3 is equal to 0. Okay, let's try and factor this. So we'll find the factors of 8 times negative 3 that add to 2. So 8 times negative 3, what's that? Negative 24. What are the factors of negative 24 that add to 2? I think probably some sort of combinations of 6s and 4s. Okay, they have to add to a positive number, so the smaller one has to be negative. So these multiply to give negative 24, but they add to give 2. So how about we write this as an 8y squared plus a 6y plus a negative 4y minus 3 will be equal to 0. Let's group the first two terms and the second two terms. Okay, looks like we could factor out, looks like how about a 2 and a y? A 2 and a y. And we'll be left with, what, a 4y plus 3. Okay, we're going to want to factor out a negative, so let's factor out a negative 1. And we'll be left with a 4y plus 3 being equal to 0. Looks like we can factor out that common factor of 4y plus 3. So we have 4y plus 3 times a 2y minus 1, and this will be equal to 0. Okay, so really this is kind of screaming at us what the solution is for y. I mean, you could set this equal to 0 and solve for y. You could set this equal to 0 and solve for y. But I hope you can see that we can get what? Y will be equal to negative 3/4. Or over here, we could get that y could be equal to 1/2. All right, but we're not trying to solve for y, we're trying to solve for theta. So we have broken this down to solving cosine of theta will be equal to negative 3/4. And we also have the cosine of theta will be equal to 1/2. So we need to solve each of these separately. Let's go ahead and do that. So we've taken this trig equation and we've broken it down to two simple or basic trig equations. So we need to solve cosine of theta equaling to negative 3/4, but we also need to solve cosine of theta equaling to 1/2. Okay. This first one, negative 3/4, is not a nice number on the unit circle. We're going to have to use our calculator for this one. So here theta will be equal to the cosine inverse of negative 3/4. I like to draw a unit circle. Okay, negative 3/4 for the x-coordinate, so negative 3/4 is, I don't know, roughly right here. And I want to know the angles that give me an x-coordinate of negative 3/4. So there's this one here. This is the one the calculator will tell you. But there's also this angle here. This is the one your calculator won't tell you. Okay. So let's check it out. So the cosine inverse of negative 3/4. Okay, so I'm getting that theta that theta could be equal to 2.419 if we're rounding to 3 decimal places, plus 2 pi k. Okay, for this one here, I mean, this is an angle in radians of 2.419, but we could just go backwards to get to this one. So we could also say, we'll write it in red. You could also do 2 pi minus this if you wanted to have a positive angle, but I think it's easier to see that this is the same thing as negative 2.419 plus 2 pi k. Or I guess you could condense this if you wanted to saying that theta could be equal to the plus or minus 2.419 plus 2 pi k. Okay, that's only for this basic trig equation. We need to solve this one also. So we want to know when theta would be the cosine inverse of 1/2. Draw the unit circle. This is when the x-coordinate is 1/2. Okay. So we have these two angles here. Okay, cosine inverse spits out angles between 0 and pi. So this is the one your calculator will tell you. This is one the calculator will not tell you. Okay, so we could have that theta could be equal to this angle here. If you want to use the hand trick, that's when the x-coordinate is 1/2. So that'll be at pi over 3. So pi over 3 plus 2 pi k. I mean, I guess you could take 2 pi and subtract a pi over 3 to get to this one. Or we could say that theta could be, this would be the same thing as negative pi over 3 plus 2 pi k. Or I think we could condense this nicely to saying that theta could be equal to plus or minus pi over 3 plus 2 pi k. And I think this is the best way, or the most condensed way, that we can write the solution set to this equation here. Okay, let's do some more examples. Okay. Let's say we want to solve. Let's say 5 times the cosine of theta times the sine of theta will be equal to, how about negative 2 times the cosine of theta? This is our next example here. Maybe go ahead and pause the video and give this a shot on your own before we do it together. Okay. Well, I want to solve this equation, and this is what I say the most common mistake I see with equations, or with students solving equations like this. They say, "Oh, hey, there's a cosine on both sides. There's a cosine on both sides. How about we divide both sides by cosine? What if we divide both sides by cosine of theta?" And we say, okay, so now this just reduces to the equation 5 times the sine of theta is equal to negative 2. Okay, what's wrong with this? Let's think about it. What's wrong? Well, you've gotten rid of a possible solution. Notice that we're not allowed to divide by 0. We've taken out the possibility that cosine of theta could be 0. If cosine of theta was 0, if this was equal to 0, we would get out 0 equals 0. Cosine of theta equals 0 is a possible solution, or something we need to look at. So by you dividing by cosine of theta to both sides, you've kind of secretly gotten rid of a possible solution. So in general, you have to be careful about dividing out variables. You never want to do that. You always want to move everything to one side and factor. So be careful. Be careful. So what we should do here is try to move everything to the left-hand side. So this will be 5 times the cosine of theta times the sine of theta. Okay, now plus 2 times the cosine of theta will be equal to 0. Now what we want to try to do is we want to try to factor. And we should notice that each of these terms has a common factor of cosine of theta. So we're going to want to factor that out front. So we have cosine of theta times 5, let's do square brackets. 5 times the sine of theta plus 2 could be equal to 0. Now we're going to want to use the zero product property. I have two things being multiplied to give you 0. So this says that cosine of theta could be 0, or we could have 5 sine of theta plus 2 being equal to 0. Oh, or this could be the same thing as saying that sine of theta could be equal to negative 2/5. So we have both of these that we need to solve. Okay, let's do this one here first. So theta will be equal to the cosine inverse of 0. Okay, how about instead of using our calculator, let's just take a look at the unit circle. Okay, at what locations do we have a x-coordinate of 0? So here's an x-coordinate of 0. Well, there are two locations. There's here. This is the one that your calculator would tell you. It's the one that's between 0 and pi. The one that your calculator doesn't tell you is this one here. There's two locations. There are two angles that give you between 0 and 2 pi that give you an output of 0 or give you an x-coordinate of 0. Okay, well, let's think here. Well, this could be theta will be equal to pi over 2. You could do plus 2 pi k. Okay, but for this one right here, you could say, what is this? 1, 2, this is 3 pi over 2, 3 pi over 2 plus 2 pi k. But how about we start here and just add pi and jump back and forth? So theta could be pi over 2 plus pi k. That'll be the solution for this one. This one here, we have to use our calculator. So theta would be the sine inverse of negative 2/5. Okay, still going to be nice to draw a unit circle here. Okay, we need a height of negative 2/5. So I don't know, here's roughly negative 2/5. I want to find the two locations where we have a height of negative 2/5. This is the one the calculator will tell you. This is the one the calculator won't tell you. Okay, and since sine inverse spits out angles between negative pi over 2 to pi over 2, I'm not going to be surprised that it should spit us out something negative. Okay, so let's see, what is the sine inverse? What is the sine inverse of negative 2/5? Getting that theta. That theta could be equal to a negative 0.412, if we're rounding to 3 decimal places, plus 2 pi k. Okay. If we want to get this other one, what do we want to do? Well, we want to take pi and we want to add this angle. So this would be pi, and well, it's spitting out a negative, so how about we do pi, we could do pi minus a sine of negative 1/2, a sine inverse of negative 2/5. I'm doing minus because this is going to spit out something negative, so then it'd be pi minus a negative, it'd be pi plus. It'd be pi plus that angle right there. So what are we going to get here? So pi minus the sine inverse of negative 2/5. So we should get out 3.553 plus 2 pi k. If this is kind of confusing you, what I'm doing here, basically, roughly what I'm doing is I'm taking pi, I'm halfway around the circle, and I'm adding this, if it was a positive angle, I'm taking pi and doing plus 0.412. So if you do pi plus 0.412, I'm getting the 3.553. Okay. So this is the solution set. These here together. Okay, let's do one last one. Let's try to solve, or let's have you try to solve. How about 3 times the tangent cubed of theta being equal to the tangent of theta? Go ahead and pause the video and give a shot at solving this one here. Okay, let's do it. What you don't want to do here is divide both sides by tangent. Do not want to do that. You're going to get rid of one of your solutions. We need to move everything to one side and factor. So here we have 3 times the tan cubed of theta minus the tan of theta will be equal to 0. And now these terms have a common factor of tan of theta that we can factor out. So we have tan of theta. Well, tan of theta times a 3 tan squared of theta minus 1 will be equal to 0. Okay, using the zero product property, we have either that tan of theta will be equal to 0, or over here we have that 3 tan squared of theta minus 1 could be equal to 0, or we would have that the tan of theta, okay, add 1, divide by 3, and then square root both sides. So we have that the tangent of theta could be equal to the plus or minus 1 over root 3. But if we rationalize the denominator, root 3 times root 3 over root 3, this is the same thing as root 3 over 3. So plus or minus root 3 over 3. So actually, we have 3 basic trig equations we need to solve. We have tan of theta being equal to 0. I'm going to erase a little bit of this here, just to leave ourselves a little bit of room. We have tan of theta could be equal to negative root 3 over 3. And we also have to think about when tan of theta is equal to positive root 3 over 3. I think all these are nice numbers on the unit circle. If not, we would have to use our calculator. Okay, so when is tan of theta equal to 0? Okay, let's draw the unit circle. Well, at what locations do I have a slope of 0? Well, that would be here, 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 here. So we could say, how about theta? Theta, so that would be, say, this is the one your calculator would tell you if you did tan inverse of both sides. There's also this one here that the calculator doesn't tell you. So theta, you could say it could be, what, 0, 0, 0 radians, plus, you could do pi k to get to both of those. Or you could just say that theta will be the same thing as pi k. Okay. Over here, we want to know when is the slope root 3 over 3 and when is it negative root 3 over 3. Okay, I think that'll be here. So that's when the angle is pi over 6. That's when we'll get the positive slope of root 3 over 3, but there's also this one here. This is when you'll get a slope of negative root 3 over 3. So this will be at, your calculator would tell you a negative pi over 6, but there's this location over here that also gives you that same slope, and there's a location over here that also gives you that same negative slope. So we could say that theta could be equal to pi over 6 plus pi k. Or we could say that theta could be equal to negative pi over 6 plus pi k. But you could condense this even more by just saying that theta could be equal to the plus or minus pi over 6 plus pi k. And this is the answer here. Okay, so that's all I have for this video. It's all we really have for section 7.4 on solving trig equations. What we're going to be doing in the next section, 7.5, is again solving more trig equations, but they're going to be a little bit juicier, a little bit spicier. In that section, where the trig functions will have different periods, or we might have to use some of our new trig equations that we learned in 7.2 and 7.3. We might have to make trig substitutions to solve equations. We'll see you there. Take care.